Hi there, hope you guys are excited for the part 2 of this procedural props tutorial. If you haven't seen the first part, I strongly advise to go check it out right now. Today we're gonna see how to create a setup for the supporting piece of the torch, and we'll end up covering how to turn this graph into a tool more user-friendly and even generate UVs on our procedural model. Let's dive in. So first thing to address, you guys noticed that Bevel primes were not available in Houdini 18, so alternatively what we could do would be to create a group just before the poly bevel that we're gonna call base, and basically add a group transfer just after the poly bevel and call the group base in primitive groups and reduce the distance threshold. This way, once you load the base group in the blast node and delete node selected, you should end up with the same result that the Bevel primes. So now we want to work on the supporting piece. We're gonna start by dropping a line that we're gonna fit onto the geometry of the torch, like so. Let's scale to fit and add a transform. Let's merge those together. And in match size, we want to justify the Z axis to the minimum of the torch. And let's rename the transform orientation torch. As soon as we start changing the rotate X, we see that the line is following the torch in the Z axis. So that's great. We may want to clean by using $Zmax and $Ymin to move the pivot to the base, like the sphere of the torch. So it seems like it's keep its position to 0, so that's great. Now we can use a curve to draw some ornament for the top of the support. So I'm going to make like a S shape like so and resample it. I don't want to use length. Let's treat polygon as subdivision curve so that it's getting smoother, and increase the segments. Okay, we can refine the shape a little bit, try to find something cool. Okay, that sounds about right. Now what we want to do is fit this shape at the top. So we could first resample the line, the baseline that we have, and we're gonna procedurally select the top point. To do so, let's just use a group range and invert range with 1 at the end. So like that, when we use a delete node in point and we are selecting the top point, it's now keeping the point that's at the top. So that's pretty straightforward. Let's use a copy stamp on which we're gonna copy the ornament to the point position. Let's uncheck transform cumulative and click a bit the rotate to find the proper orientation. Once we merge that with the torch, well, we'll also need to merge with the main line. So I'm figuring out that the rotate seem okay with 90, 0, 90. Now what we want to do is fuse the points of the ornament and the main line together. To do that, let's create a group for the ornaments, and we're gonna just call it base and group type to point, and in base group let's just add 0 as a point. Now we can use a group combine and group the base with the top point. As soon as we fuse the base group, now it's completely fusing the line together, so that's great. We just got one primitive for the line. We can drop a transform and add an offset to the ornament if we want it to be higher. Yeah, that's could be an interesting feature to have if we want. So now as soon as we change the rotate X, it's still following, so that's great. Okay, we're gonna give some shape to this line. Let's drop a sweep node, and we'll also use a grid as a cross section. Let's drop down rows and column to 2. A smaller size, and change orientation to XY plane, and drop a skin to add some proper faces. It's a bit stretched, so let's reverse the point before the sweep should fix everything, and then reverse again after the skin so that the normals are in the proper direction. We could use a polyfill to end the caps, and seems to work, so that's cool. Let's make some room. Gonna organize the graph as I go because it's gonna be very confusing otherwise. So let's drop a point VOP and a transform. I'm gonna change the translate Z, add some color. Well, actually, I'm thinking we could just reuse the setup we had in the first part. Like this node, let's call it spline, Control 1, copy it and paste it in here so that we don't have to redo the whole setup with the mix. So let's just delete the point of the spline and just create a new shape. So I pretty much just want a bulge in the center of the line. Something like that. That could be an interesting breakup, I guess. So let's plug the merge back, and well, we need some normals on that guy, so let's add a normal. Looks right. So as soon as we move the points, it's perfectly working so far. So we're gonna use a bind export and call it SplineVal. And as we can notice, all the values in the curve that we have are above 0. So we could just use a delete node. Let's set it to point and delete by expression, and we're gonna type @SplineVal greater than 0 and delete non-selected, and now we just get this shape that we just created with the spline. So what's interesting with that is that it's going to drive a lot of things in your setup. So let's just use a group range to in point mode so that we can partition the spline in two. Let's call that middle. Now what's cool is like we can blast this section, and we can notice that the point number 0 is actually the one in the middle of the shape. So I'm just using the delete entity points, delete non-selected, and I just keep the point number 0. So that will be the middle point of the shape we draw. So what's cool is now we can add a shape that's going to be driven by the middle point, just with a copy. You can merge this copy back into our setup. Let's give it a proper orientation. So XY plane, and oops, no, let's play with the rotation. This one, so Z rotation 45 degree, and reduce the rows in column to 2. So we can use a match size to refit the position of this polygon to the proper space. That's cool. So this way it will always fit the minimum Z axis. So that's pretty cool. So that seems to work. That's the proper position. Now we could adjust a bit the size, add some green on that node. We're gonna need to expose some parameter later. So now when, okay, so we got a problem because we need to set those to none so that when we move the point, it's not trying to fit in the middle of the object, but keep following the middle point in our copy. Let's give some more shaping and subdivide our grid. So creating a group of points that we're gonna call corners, and just after that group transfer. So now start to be familiar with that technique, I guess, and call the corner group, reducing the threshold to be sure they are perfectly matching the points of the original shape. And as soon as we use a soft corner, we can control those points. So let's center the pivot to the center of the group. And now we can do some more tweaking with soft radius, maybe try to increase the subdivisions, play with soft radius, play a bit more with the scale, the size of the, maybe let's drop a transform at the just before the soft transform so that we can stretch this shape, and center the pivot to $CEX, CY, CZ. Yeah, fun stuff. Let's now give some thickness with the poly extrude and output back. Add some color to this guy. Let's call it thickness. So soft transform is gonna be shape corners, and the transform is gonna be stretch. Right. So I think we haven't done that yet. Let's make a subnetwork out of those nodes, and let's call it cross support. So what's cool about that, it's like grouping our nodes together, and we can expose some parameter. So let's just make those invisible. We don't need to see the inputs, and expose, drag and drop with the left click and drag into the root. You can always change the label of the parameters we want to expose. Let's take the soft radius as well, and the scale, let's call that stretch. The other was the corner scale, and we could also take the extrude distance that we're gonna call thickness, and we can of course create a group of parameter that we're gonna call base support. So that's pretty cool. It's exposing just the parameter we need. Maybe let's drop a poly bevel. So this time, instead of using ignore flat edges, we're gonna make a group of edges ourselves. So let's just drop a group, set it to edge, and enable minimum edge angle so that we just pick whatever we need and call this borders. Just need to call this border group into the poly bevel and adjust the offset. Can always tweak the divisions. Yeah, that sounds about right. Add some color for the bevel, and we're gonna add some parameters, like we wanna add the divisions, bevel div, and create a float called bevel intensity that we copy parameter and just paste it as a relative reference into the offset, and now it's working as well to the root of the subnetwork. Just limit the range between 0 and 0.1. This way it's a bit more handy to deal with that parameter. Back into the merge, so we're gonna need some normals as well. Let's decrease that, and can always decrease the size of the original grid if we want. Let's work on the bolt setup now. So after the match size, let's add a poly extrude and do a little inset. We're gonna uncheck output side. This way when we do the inset, we just decrease the size of this face. So actually let's move the extrude inside the subnetwork, delete the points we've added, and do a group range. This way we'll be able to isolate the two most important points. So let's switch that to point and call this group bolt. We can create a copy and use a sphere as a base for our bolt. And don't forget to add the bolt into the template group. Just gonna change the type to polygon mesh and orientation to z-axis. Decrease the scale a little bit, and I guess we could delete the unnecessary faces, so let's just use a delete node, entity to point, and use a bounding volume that we're gonna move to like split the sphere in half. Can do a polyfill to add the cap, just a single polygon, and add a poly bevel just to give a more like round edge. Let's merge the bolt into the main setup, and we can expose some parameter in a group that we're gonna call bolts. Let's actually make the group type too simple and drag and drop the most important parameter. Being set, we are calling distance, uniform scale for the bolt that we rename scale, and now we can have some basic control over the bolts. It's time to add a bit more shaping to this guy, so let's just copy the spline control node setup, and instead of moving, we actually gonna first center the pivot and reduce the scale, like to something like very small in X, and let's delete the points that we had. Actually, I'm just gonna switch the inputs so that, yeah, I'd rather have this configuration. So basically now trying to find some cool shape, switching between the different types, linear, B-spline. Can always increase the width of the grid. Yeah. So actually it's a pretty cool way to really design and add some breakup into the shapes. It's pretty fun. Let's plug the merge back into the last node. So it's looking better, but it's still very straight. So we're gonna try to bend this guy a little bit. We're gonna use the same spline control again. This time we're gonna do a translate in Z, I think. Yeah. And just copy the spline control again. Same deal, we just delete the points that we had and adjust the curve to influence the bending. So it's looking much more interesting. Can increase more or less the bending. If we want, we could add a little offset into the cross support so that it's not intersecting so much. So actually, we're gonna sharpen the normals on that guy. So let's reduce cusp angle to 20. And we're gonna create a deformation on that guy. So let's just add an assemble node and create back primitive to extract the center and delete the primitive we've add. Then we could use a group on which we're just gonna group the point that we have and call it center, since it's the center of the cross. And we could use a group transfer to transfer the center point to the geometry. Now when I use a soft transform, well, okay, I see what's going on. I should have switched the group type to point and intercenter into point group for the transfer. Now we can call it into the soft transform. And as soon as we start playing with soft reduce, translate Z, we got a little like deformation You may need to adjust the normal, otherwise might create some weird faces. And again, it's time to expose some parameter. So let's create a group that we're gonna call Deformation. And let's drag a float in this one that we're gonna call Translate, and drag and drop the soft radius. Okay, so now we can copy the parameter of Translate and pass it as relative reference into the Translate Z of the points. So now we can control the deformation from our from the root of our subnetwork, so that's really cool. It's time to work on the wire system that's gonna link the torch to the support. So let's grab the middle of the cross that we had and add a line. We're gonna use a copy stamp to actually like position it to these points and orient it toward Z. We can group the point at the end with base group 1 and call that to project. What we want to do first is define an intersection geometry. So we're going to use another copy that we're going to copy on this point and use a box that we're going to use as a boolean with the torch. So I'm adding a null toward the main branch so that we can plug our boolean, and as you can see, we now get the intersection and we can project the point with a ray node. So in group, let's not forget to project point and minimum distance as method. We can rename the null boolean intersection, and let's create a circle that we're gonna copy onto our to project point. We can change the orientation to ZX plane, convert that as a polygon, of course, and let's add a poly wire. We can connect that to the main merge, and we see that the circle is a little too big right now. We can add some normals and adjust the scale of the circle. We can also tweak the radius and add a little offset by using the center values. Gonna add some nulls and rename everything so it's not too confusing. So that's gonna be output wire support. Output wire support. Okay. So we want to create an overlay to project the last point of our line to the new geometry. So let's switch that to minimum distance, group to project. It doesn't work because we need to plug the collision to the ring that we have. And then let's add some colors and stuff. Okay, you can alt click to create a little derivation if it helps cleaning your graph. And I'm just copying the poly wire to the line and merge that together. So that's pretty cool. We can actually have a carve node if we need to trim a little bit of the line so that's not intersecting too much with the ring. Let's make some more room because it's getting very confusing. So I'm creating another copy node from the middle point that we had and copying a torus. Adjusting the radius and uniform scale just to have a contact point between the wire and the support. Kind of help blending things together. Okay, if we now try to adjust the rotation, everything is following properly, so that's great. There's just like a little gap now between the bottom of the handle because of the bending that we had, so let's just compensate the offset with a transform just before the Boolean intersection and pass as relative reference the parameter we had in the bending transform. And let's rename this new one offset compensation, and the one we had offset deform. So if we tweak the values, it's still adjusting the position of the torch. That's cool. Okay, there are still a few details we need to adjust. We can see there is like some two large faces that we can clean with Resample just before the sweep. And let's actually add a group where we're gonna do an edge group. We're gonna call it borders, and just use the minimum edge angle to select the borders of the shapes. So as we can see, there is like a weird face that's not been fused properly, so we can fuse that after the sweep and it should work properly. Now we can adjust the bevel and call the border group we just created. And now it's time to be creative with bevel, so feel free to even try profile. Sometimes you get some pretty interesting stuff going on. Yeah, oh, that's too much. I know Houdini 18 got some very interesting bevel update, so I'm sure you can play with that too. So okay, doing some changes here and there. But our graph is pretty much ready to be turned into a subnetwork. So let's click subnetwork and call that torch tool. Can make that invisible. So I'm gonna speed up this part because we already seen how to do that, and now it's just a matter of taking the parameters we have inside the green nodes we exposed all along the two-part tutorial and turn this into a like user-friendly tool. As you can see, you can always like drag and drop stuff into group, create your own like a float variable, pass that into a relative reference like in a bevel, and yeah, you just expose whatever you need for your tool basically. And now it's just so much more fun like to do some tweaks on the model because you have all the key parameters in just one node, so that's really cool. So for the ornament, you can always like copy the curve that you had and do some other variation. Like I'm trying to find some other shapes really quickly and add a switch. I'm gonna create a custom integer into a folder that I'm calling support, and it's just gonna call that shape top, and copy the parameter and paste it as relative reference into the switch. Now as soon as you change the integer, you're actually switching shapes for the top. UV wise, we can always use the game dev auto UV that you can find into the game dev kits update. So with that node, you basically got to control grain tolerance and merge threshold. So with these two parameters, you can do pretty much anything. It's not always like perfect, but at least for like automatic like setup, it's just like super convenient. So I'm not going to show how to manually unfold all the pieces, and even if we can automate that, I mean, with this tool that actually you already get some decent stuff, and then you can add a UV layout at the end to pack into UDIMs or anything, and as soon as you drop a visualize node, you see what's going on. So if we want to create UDIMs, we can just turn that to UDIMs and define a limit for the number of rows. Okay, so I took the time to expose all the parameters and organize everything into groups and everything. There is also a UV tab where you can enable all the UVs, change the tiling of the visualization, and also individually enable the UVs on any specific section, just in case, I don't know. So this is how the graph looks like once it's cleaned, and as you can see, I added some backdrop to clean everything, and these are the parameters that control the activation of UVs. Also added a bunch of backdrop of sticky notes to add some titles. You can get this script into my ArtStation store. It's available for free. There are a couple of things I wanted to address that I totally forgot while recording, is that as soon as we change like the position of the bolt, it's interpenetrating with the cross. So there is a little technique using a point deform that I use to actually make to fix that. So as soon as you enable that, it's now following the deformation of the cross. So that's pretty handy. Sometimes it gives some weird artifact because you need to crank up the number of points in here, like let's say 5. It seems to work, and yeah, you can play with that, and it's perfectly following the shape. One other thing is that the rings at the top of the cage were not really following the shape of this cage. And so what I did is I created a ray node to reproject the rings on the cage. Then the problem is completely deforming the rings. So I just created a for each connected primitive and created a tube node on which I copied and pasted as relative reference the number of columns. So that's pretty much it for that. And now, as you can see, if we start changing the shape of the cage, it's perfectly conforming to the changes. And so that's really cool. Let's output everything. Let's reset some values. It's a bit too much. You can always actually add some limits if you think you don't need too much room into a parameter. You can limit, let's say, to 1, and it won't slide above 1. Well, still too much, so I'm gonna reduce to 0.45. And yeah, that's way better, I think. And that's just taking quite a bit of time and testing. Can always change the shape, so that's cool. One thing that's pretty fun now is we can add a bunch of rings and pretty much scatter them along this this cage, so that's pretty fun. So that's pretty much it for today, guys. Do let me know if something wasn't clear. I'll try to address that in another tutorial. I hope it's been useful. Then again, don't hesitate to share your result with me on social medias. I'm always eager to see that. My contacts are in description. And if it's not already done, please subscribe to my channel so you won't miss some more exciting content. And what's coming next is gonna be pretty awesome. So stay tuned and see you guys very soon.